everyone. I'd like to welcome you back to Chapter 7, Conic sections. This is what we're moving on to today. We have talked about conic sections before. We haven't gone necessarily as in-depth as we're going to go, but they are familiar to you. So, as a review, a conic section is simply a figure that is obtained by slicing a double cone. And I have pictures located below. If I slice a double cone horizontal or parallel to the base, I'm going to get a circle. If I slice it at an angle where it intersects a base, I will get a parabola. If I slice it at an angle and it does not intersect a base, I will get an ellipse. And finally, if I slice it vertically straight down, perpendicular to the base, I will get a hyperbola. The equations come in two forms. We have standard form and conic form. Standard form is a times the quantity x minus h squared plus b times the quantity y minus k squared, and that is equal to c. A, B, and C are simply constants, or numbers, coefficients. Okay, they're not in particular. They change all the time. They're just placeholders for where our numbers would be. Conic form is if I take standard form and I multiply it out and I set it equal to 0 and I combine all my like terms. So that would look like this: ax squared plus by squared plus cx plus dy plus e equals 0. Again, a, b, c, d, and e are just placeholders for my numbers. Today, we are going to focus on circles. Circles are the most basic type of conic section that we're going to do. And you have done these before. We studied these last semester, so this should be a review. Standard form, remember, is x minus h squared plus y minus k squared equals r squared. Notice, in my formula, it said x minus h. And when I brought it out, my center is just hk. So, just like when we did transformations, if the number is in the parentheses with a variable, it's going to come out being the opposite. In this case, both x and y have quantities that are inside with them that need to come out as opposites. My radius is r. So if I look at this equation over here, my center, x minus 3, that minus 3 comes out as a positive 3. Y plus 2, that comes out as a negative 2. So if I were to graph the circle, I would plot the point 3, negative 2. My radius is what's equal to, so it is equal to the square root of 9, which is 3. Because remember that 9 is r squared. So from here, we are going to go 3 every single way. Up, down, left, right. Those would be my endpoints. Those would be the points that I would now connect to make my circle. And you will be listing those on your assignment when we do them. Just as a reminder, down here I have the information on how to complete the square if you forgot. We are going to go over it while we go over these problems, but if you need a refresher on the examples, they are up there, or the instructions are up there for you. So let's just jump in and start with the first one. So the first thing I do every single time is I am going to group my like terms together. So I'm going to group x squared plus 2x, and because I know I'm going to complete the square, I'm going to put a plus blank. Now I'm going to group my y's together. I have y squared minus 4y plus blank. And I'm going to bring that minus 31 over to the other side, so I'm going to add 31. Now to keep my equation balanced, since I added 2 blanks to the left side, I don't want this equation unbalanced. I need to add 2 blanks to the right side to keep it even. So how are we going to fill in the blanks? We're going to look at this. This is our b. So we are simply going to do b divided by 2 squared. Now, yes, I know you could tell me that that is 1. I don't want you to write that low. I want you to write exactly what I have up there, because the more we do this, the more important it is for you to keep track of certain things, and those are going to be very important because they aren't always going to be nice and even. Okay. So if I put a 2 over 2 squared on one side, I got to put it to the other side. So the next equation, my b is a negative 4. Well, if I square a negative, I'm going to get a positive. So there's no point in me worrying about the negatives. So when I come over here, I'm just going to write 4 over 2 squared. And again, what I do to one side, I must do to the other. So from here, we're going to magically factor. To factor, we bring down the letter x. We bring down the sign plus. Half of 2 is 1. Put a squared on the outside. Let's do it again. Bring down the letter y. Bring down the sign minus. Half of 4 is 2. Put a squared on the outside. Now this over here, I will just all type in my calculator just like that and get an answer. And all of that simply becomes 36. Now we've taken something that was in conic form, made it into standard form, and now I can get all the information I need in order to graph it. My center, the x plus 1, comes out as a minus 1. Y minus 2, that means plus positive 2. My radius is square root of 36, which is 6. Notice when I take the square root of the number, the square root sign goes away. So our endpoints we're going to get as we're plotting them. So first thing I plot is my center, negative 1, positive 2. And now I'm going to go 6 every direction. I'm going to go 6 to the right. So that is the point 5, 2. I'm going to go 6 up. That is the point negative 1, 8. I'm going to go 6 to the left. So that's the point negative 7, 2. And I'm going to go 6 down. And that's the point negative 1, negative 4. Those are my endpoints. Those are the points that I'm going to connect. Now you know me in drawing, that I'm going to connect the best that I can to make a circular shape. The bigger they are, the harder they are to make into a perfect circle. So just know that I expect your best effort when graphing them. It should be a round-ish shape. And going through all the points. And there's your circle. Okay, let's move on to example 2. We are going to start this process exactly the same. We are going to group our x's together and our y's together, leaving a blank for our completing the square. So it would be x squared minus 6x plus blank plus y squared minus 8y plus blank. And we're going to move that constant to the other side, so that's a negative 18 with 2 blanks over there to keep our equation balanced. So first thing we're going to come to is this 6. So in my blank, I write 6 over 2 squared. What I do to one side, I write on the other. Go to the next one, negative 8. So that's 8 over 2 squared. Write it right there. So now we're going to factor. So that becomes x, bring down the sign, half of 6 is 3, square on the outside. Plus, bring down the letter, bring down the sign, half of 8 is 4, squared on the outside. Again, we type everything on the right-hand side into the calculator, and I get 7. Now that we know is not a perfect square, and that's okay. Everything you do is not going to be a perfect square, but we're going to just use when we're graphing the decimal approximation. So my center is at the point 3, 4. My radius is square root of 7, which is 2.6 approximately. You don't need to go any further than a tenth because you're estimating where they are on a scale of 1 anyway, so that's as far as we need to go. So first things first, I plot the point 3, 4, and then I go 2.6 either way. So that's 2 and a little past half. Go up 2 boxes and a little past half. Okay, left 2 boxes and a little past half. Down 2 boxes and a little past half. Use those points, connect them the best you can to make a circular shape. Make sure you list your endpoints so I know what you're using to make the shape. So that was 3 and 6.6, 5.6 and 4, 3 and 1.4, and 0.44. Okay, as you're going through this, if you have any questions, make sure you email me. I'll be happy to answer them. So up until now, we haven't had to deal with a coefficient. So let's look at example 3. It has a coefficient we're going to have to deal with, and that's okay. So what you will notice is that in a circle, your coefficients for x squared and y squared should be identical. If they are not, you do not have a circle. So in this case, my coefficient is 4. So the first thing I'm going to do is I'm going to divide every single thing in the problem by 4. As I do this, I'm going to regroup my x's and my y's together. So 4x squared divided by 4 is x squared. Negative 20x divided by 4 is negative 5x. Put a plus blank. Now my y's, for a circle, it's always a plus in the middle. We have y squared. 8 divided by 4 is 2y plus blank. We're going to move the 15 over to the other side, so that's 15 fourths. It doesn't go in evenly. I want to just leave it as a fraction. It'll work its way out in the end. So here we are going to start the first blank. So it's going to be 5 divided by 2 squared. Okay? I know that's not a nice round number. That's fine. We don't have to worry about it. Our calculator is going to be doing all of this for us. Okay, just put it on the blank. Then I go to the next one, 2. So that's 2 divided by 2 squared. Put it over here. So now we're going to factor. So this becomes x minus 5 divided by 2. I can't do it. I just leave it as 5 halves. Put a squared on the outside. Plus y plus 1 squared. And all of that over on the other side, when you put it in your calculator, comes out to a nice, neat 11. So even though it looked like it wasn't going to be nice round numbers, we still ended up with some. Okay? So from here, my center is 5 halves, but since I am going to be plotting it, I am going to put the decimal. So it's 2.5 and negative 1. My radius is square root of 11, which is approximately 3.3. So I would plot my center, so positive 2.5, negative 1. And then I go 3 1/3 boxes. 1, 2, 3 1/3. Up 3 1/3. 1, 2, 3 1/3. Okay, I would then connect all of those points in the best looking circle that I can. And as long as I've done my best and write the coordinates down, that's all you need to know. So it's 2.5, 2.3. It was also 2.5, negative 4.3. 5.8, negative 1. And finally, negative 0.8, negative 1. That's all there is for circles, and if you have questions, please let me know. Thanks.